Yeah.
Okay, so you have a first order linear differential equation. First order linear differential equation here. And remember, the formula is if you have y prime plus px, y equals to qx, then you write your m of x as e to the integral of px. That was the formula, right? And you multiply that to here. Now, if you compare this with that, you can see two things. First, here's a plus, there's a minus. That you should take note of that. And there's nothing here, and there's x here. Okay, that means when you try to compare them, you have to be very careful. Unless you have one here, you can't really say this is same as that, right? So what should we do?
Divide by x.
Divide everything by x. You have to do that. Without that, you won't be able to apply this formula. So you divide by x, you get y prime minus 5 over x, y equals to 2. And then if you look at this with that, I see a plus here and there's a minus here. So what should your px be?
-5 over x.
It should be negative 5 over x. You have to include a negative sign. If you say px is just 5 over x, then these two don't match. So many mistakes that I've seen were people forgetting to divide by x, and the next mistake was people forgetting to include the negative sign. Right. So then the next part is clear. M of x is e to the integral of negative 5 over x, which is e to the negative 5 ln of x. Now, it's very tempting to cancel e with ln, but you can't because of this negative 5 in the way. What do?
Log over the logs.
You make it jump over the log like a frog. Then you can cancel them, which gives you x to the negative 5. All right, here's another place where a lot of people make mistakes. You take this, and some people think that this is the multiplier to be multiplied to the original equation. That's wrong. Where are you supposed to multiply this?
To the
This
opposite arrow.
one. You have to multiply to this one. Because this multiplier was developed for this equation. It wasn't developed for anything else. It was developed for this equation. So you have to take this and multiply it to the one you made into standard form. Okay? So those three are the common places where people make mistakes. Okay. All right. So you multiply this and you get x to the negative 5, y prime minus 5x to the negative 6. And you should think about why this is x to the negative 6. This is x to the negative 1, right? X to the negative 1 times x to the negative 5. That's negative 1 plus negative 5. That's x to the negative 6. Y equals to 2 times x to the negative 5. And then now check that this is really a product rule. Okay? Is it? I'm trying to claim that the left side is a product rule of this. It's always that case, right? You take this part and move it down here with prime applied to the entire thing. So let's see, if you did apply the product rule to this, when you differentiate y, you get this first term. When you differentiate x to negative 5 will come up to the front, and this will be negative 6, which agrees with this. Okay? So this definitely, when you apply the product rule, this definitely turns to the left side, so you know you did everything. Right, and then you integrate both sides, you get x to the negative 5, y, integrate 2 to the x to the negative 5, dx, and then that's x to the negative 5, y. Let's see, you have to add 1 to the exponent and put the reciprocal front, you have to put plus c, and then x to the negative 5y is negative 1/2 x to the negative 4 plus c, and then you multiply by x to the 5th power both sides to get rid of x to the negative 5. They cancel and you get y equals negative 1/2 x to the 1st power plus c times x to the 5th power. You're almost there. Now you only need to check whether this is true. Y of 1 is equal to 0. So that this actually has to be translated as when x is 1, y is 0. That's what it means, right? So you plug in x equal to 1 and y has to be 0. That means c has to be 1/2. And that should be plugged back in there. Therefore, your answer, final answer is y equals to negative 1/2 x plus 1/2 x to the 5th power. So that is the solution of the given